Hi friends, welcome to our channel. In this we will discuss role of lexical analyzer. So lexical analyzer is the first phase of compiler. Now in this role of lexical analyzer we mainly discuss four topics. Now first one is the functions that are provided by the lexical analyzer. Now second one is the separation of lexical analyzer from syntax analyzer. The separation of lexical analyzer from syntax analyzer. What are the different tokens, lexemes, and then patterns that are provided by the lexical analyzer? Finally, different types of lexical errors. These are the main 4 points that are related to lexical analyzer. Now we will discuss each and everything in detail. So the first one is different functions of lexical analyzer. Functions of lexical analyzer. Everyone know what do you mean by lexical analyzer? Lexical analyzer reads the source program character by character and then generates a stream of tokens. Stream of tokens. What do you mean by token? Token is anything that is either a variable, constant, operators, identifier, everything is a token. So different functions that are provided is simply lexical analyzer reads the source program, right? And in the source program, it removes comments. That is, at the time of token generation, the comments are not considered. Remove comments from the source program, and it removes any white spaces. Removes any white spaces in the source program. What do you mean by white space? Any blank spaces or new line characters or tab spaces, all such type of spaces are removed by lexical analyzer, and then the lexical analyzer count the number of lines a source program contains. That is, the inputted source program have how many number of lines. It counts the number of lines of the source program. Along with this count, the lexical analyzer maintains a symbol table. You know the meaning of symbol table. Symbol table is used to know the entire information about the token. So that symbol table is also maintained by the lexical analyzer. Finally, the lexical analyzer generates some errors. Actually, the errors are generated by the lexical analyzer, but these errors are given to some error handler. The errors that are generated from the lexical analyzer are given to error handler with line number and column number of the error. That is, in the entire program, it counts the number of lines. At which line the error occurred, at which column the error occurred, the entire information of error is given to error handler. These are some of the functions that are provided by the lexical analyzer. Now the second thing is separation of lexical analyzer from syntax analyzer. Before knowing that thing, you have to know what is the interaction. Before knowing the separation, you have to know the second point simply is how the interaction of lexical analyzer and syntax analyzer. Simply, this is the source program. This is the source program. The source program is passed as input to the lexical analyzer. You know that one. Now this is the syntax analyzer, right? Originally we assume that first the source program is given to lexical analyzer, and then lexical analyzer generates the tokens. That token is transformed to syntax analyzer. This is our assumption, but originally it is not true. First, this syntax analyzer request for a token. Request for a token. Whenever syntax analyzer request for a token, now the lexical analyzer reads the source program. This is the first step. Now the lexical analyzer reads the source program and then generates the token. The generated token is given to syntax analyzer. This is the third step. You got it? First to syntax analyzer request for the token. Once the request for the token to the lexical analyzer, this lexical analyzer reads the source program and then generates the token. The process is repeated until all the tokens of the lexical analyzer is completed. At the same time, both lexical analyzer and syntax analyzer maintains symbol table to store complete information related to tokens are placed in symbol table. Both LA and SA maintains information of the symbol table. This is the first step. The functions of the lexical analyzer. Okay, I think clear. Now move to the second phase. Now the second point in this rule is separation of lexical analyzer from syntax analyzer. Separation of lexical analyzer from syntax analyzer. We have different rules. They are using different reasons for separation. One such reason is to simplify the design of a compiler. Simplify the design of a compiler. This is one reason. To increase the efficiency of a compiler. Increase the efficiency of a compiler. To enhance the portability of a compiler. So to simplify the design of a compiler, to increase the efficiency, to enhance the portability of a compiler, you know that one. Design in the sense simply to design the compiler. Efficiency means the performance is to be increased. Portability in the sense it has to be run on many different compilers. Along with this, actually these are technical terms. Originally, the main purpose of this separation is, suppose you are a person, I have given many workload to you. It is not possible to handle all the works. That is the reason the entire work is shared among different persons. So, simple thing is to reduce the burden. To reduce the burden on a single phase, we are dividing the burden into, that is the work into different phases. This is actually the main reason. Once, for example, a task is given to me, it is very difficult to handle the task. It is not completed within the given span of time. Then the efficiency is decreased. Suppose the task is divided among two persons. So automatically the performance, the efficiency is also increased. That is the reason. In simple terms, for you technically, lexical analyzers are used to implement regular expressions. Lexical analyzers are used to implement regular expressions. The regular expressions are identified by using finite automata. Syntax analyzers uses context-free grammars. Context-free grammars are recognized by using push-down automata. You got it? That is, the different types of problems are categorized. The set of regular expressions are identified by using lexical analyzer only. The problems related to context-free grammar are identified by syntax analyzer. That is the reason we are making separation from lexical analyzer with syntax analyzer. You got it? These are the main important points. Now the third one is token, lexeme and pattern. What do you mean by token? Simply lexical analyzer reads the source program character by character and generates tokens. A token is Any valid identifier is a token. Keyword is a token. Operator is a token. Semicolon, suppose comma, full stop, and some punctuation characters all are considered as a token. Simply, suppose int a is equal to 10. In this, int is a token. This is a keyword. A is token. This is an identifier. Is equal to is a token. This is operator. 10 is a token. This is constant. This is called token. And remember, every token is represented as a pair. The first one is token name and the second one is attribute value. What do you mean by this one? Token name in the sense the name of the token. The attribute value is simply a pointer that is used entry into the symbol table. You know the concept of symbol table. Already we discussed. Lexical Analyzer maintains a symbol table. It is used to identify or to know the complete information related to token. Suppose 1. ID1, 2, ID2 like this. Here ID1 is the name of the token, 1 is the attribute value. So by using 1 it is easy to move to the ID1. Along with this name, symbol table contains lot of information, that is the scope, value, some other information also. This is the token. Lexeme in the sense simply a sequence of characters. A sequence of characters that are, suppose sequence of characters in the source program that are matched by the predefined language rules. Simple thing. A sequence of characters in the source program that are matched by the some predefined language rules used for every lexeme to be converted into a valid token. That is, they are using simply set of characters. Suppose consider this statement, int a is equal to 10. How do you represent the lexeme and how do you represent a token? Simply lexeme is equal to int. This is a predefined language rule. It satisfies some predefined language rule and sequence of characters in the source program. Now what is a token? Token is int is a keyword. So simply a keyword. Or you can represent like this also. ID comma 1. ID comma 1. Okay. Suppose A. Actually int is not ID. Int is a data type. Simply it is a keyword. For example, A. A is an identifier. So here A is a lexeme. A is a lexeme. It is an identifier. Identifier is represented by using like this. Assume identifier name is ID. Attribute value is equal to 1. For example, some B plus 10. If you have a statement like this. Now is equal to is an operator. Like this we can represent directly assignment. Suppose B is an identifier. Here you can write like this, ID comma 2 like this. Suppose next plus is equal to operator. Next 10 is a constant. So if you have identifiers, you have written this identifier name of the token along with attribute values. All the identifiers are stored into the symbol table. So this is the main difference between lexeme and token. Lexeme is a sequence of characters that are matched by the language rules. For every lexeme is to be converted as a valid token. So int, this is a lexeme, a sequence of character. How do you convert into a token? Keyword. A is a lexeme. ID comma 1. This is the token. Simply the thing is same in different representations. So token and lexeme are completed. Now pattern. What do you mean by pattern? The name specifies pattern. Simply it follows some set of rules. Pattern is simply some set of rules that are used to define a token. The set of rules that are used to define a token, and the patterns are used to define regular expressions. The patterns are used to define regular expressions. Suppose now I will write down the pattern for identifier. You know the concept of identifier. Identifier is any name given to either a variable, function, array, structure, etc. And identifier contains letters, digits, and underscore. Only three are allowed. Letters in the sense A to Z, digits in the sense 0 to 9, and the only special character is underscore. What are the rules you have to follow? Compulsory identifier begin with either a letter L or an underscore. Here the symbol represents R, this is L. Identifier begin with either a letter or underscore followed by either 0 or any number of times, either letter or digit or underscore whole star. Star represents 0 or many number of times. This is a pattern. That is, it follows some set of rules to define a token. For example, A underscore, this is a token. A underscore 2, this is a token. By using the set of rules, regular expressions and tokens are developed. This is the concept of token, lexeme, and pattern. Okay, one is lexical errors. Simply lexical errors in the sense the errors that are generated by lexical analyzer. The errors that are generated by lexical analyzer are called lexical errors. Some common lexical errors are, some general lexical errors are spelling errors, spelling errors in the sense, suppose I am using if condition. If is the actual condition. Suppose instead of F I am typing D. Instead of F I am typing D. That is, during the program writing, if you do any spelling mistake, suppose main is the word M-A-I-N. Suppose instead of I, KD. So spelling mistakes, such errors are called spelling errors. This is one simple spelling error. Next one is unmatched strings. Unmatched strings in the sense, string is a group of characters enclosed within quotation. For example, S is equal to good. Here you have to close. Here you have to close the string. Suppose I forgot to close the string. That is called unmatched strings. So spelling errors means by mistake we are writing another sentence. Unmatched string in the sense, compulsory if you have a opening, there is compulsory a closing. Now, appearance of illegal characters. Illegal characters. What do you mean by illegal characters? For example, I am declaring some variable int I comma j ended with semicolon. That statement is clear. Suppose followed by you are writing some symbol dollar star. Those symbols are not considered. So illegal characters, this such type of symbols are not allowed. Or suppose int 9a. This is invalid. Why? An identifier begins with a letter or underscore only, but it does not begin with a digit. So such type is also not allowed. These are called illegal characters. Now the last one is exceeding length of the character. Exceeding the length. Exceeding the length in the sense, each and every identifier have some fixed length. Suppose consider C language, a variable is declared. A variable has a maximum of 32 characters. A variable have only 32 characters are allowed. Suppose if more than 32 characters, it leads to error. Suppose coming to Python, actually there is no restriction on the name of the Python variable length. So these are different types of errors. Now, how do we solve those errors? That is also very important thing. Once such type of errors occurred, it is very easy to solve the errors. First one is simply delete that particular character. Delete a single character. After deleting the character, it leads to the good token, that is a valid token. Suppose if you have a dollar, remove this dollar. After removing this dollar, this token is a valid token. Delete a single character, or you can delete successive characters. Not only a single character. Suppose if your token contains only one invalid character, you can delete. Or if it contains more than one successive character, suppose MAKDIN. So these two, once you are deleting these two successive character, main is the valid token. So delete such type of successive characters, or replace one character with another character. For example, ID. For example, or consider this one, MAKD. Simply replace K with I. Replace K with I. After replacing MAIN, sorry, not KD, MAIN, that is the valid one. So whether single character removal or successive character removal or replacement is removal or transposition. Transposition in the sense changing the position of the character. Suppose if your string is MANI, simply by changing that string is converted into original format. And finally, you can insert a missing character. Suppose I forgot to type I. Simply insert. You got it? Very simple. During the typing, if any common mistakes we are doing, that common mistakes are rectified. Either deleting a single, or inserting a single, or replacing, or exchanging, or deleting multiple. Whatever it is, after performing this operation, you have to produce a valid token. These are different roles of lexical analyzer. Simply the functions of lexical analyzer, and then the interaction between lexical analyzer and syntax analyzer. What are the different regions that are used for separation of lexical analyzer from syntax analyzer? What is a lexeme? What is a token? What is a pattern? What are different types of lexical errors? And this final thing is, how do you resolve that particular types of lexical errors? Okay, thank you.